Hello, this is going to be the video for proving lines are parallel. This is going to be similar to the lesson that we did on parallel lines proofs, all right? Except we're going to kind of look at it backwards, right? Instead of being given that lines are parallel, we're going to try and prove that lines are parallel and how to do that. So the theorems that we're going to be actually working with, they're all going to be really similar to the theorems that we've already learned, just in reverse. So if you remember that if you take a conditional statement and switch it around and read it backwards, all right, we call that the converse. Okay, so this is why we kind of learn that. It's so that we can learn the converse of some theorems. And the converse of all these theorems basically takes what we already know and says that if you prove some certain things about the angles, then you can prove the lines are parallel. So we're going to learn four converses here with our four theorems and postulates that we had before. So the first one is the corresponding angles converse. So we can say if we got two lines that are cut by a transversal, and if you can actually show that corresponding angles are congruent, all right, then the lines are parallel. So it works both ways. If the lines are parallel, then corresponding angles are congruent, or if corresponding angles are congruent, then lines are parallel. And that's really, how all four of these are going to work. So we've got our alternate interior angles converse. So we can say if alternate interior angles are congruent, then the lines are parallel. We've also got our alternate exterior angle converse. So again, if alternate exterior angles are congruent, then the lines are parallel. We can also say same side interior. Now, this one's a little bit different, okay? Because if you remember, same side interior angles aren't actually congruent, all right? So this is, the only one that's different. They have to be supplementary, okay? Which means they add up to 180. So if you can prove that same side interior angles are supplementary, all right, then the lines must be congruent, okay? So we're going to, use these in some proofs. We're also going to do some solving for x problems, all right, because this is something that you're going to have to do. So the first question says, find the value of x that makes the two lines parallel. So what we're kind of looking at here, all right, we're looking at two angles that are alternate exterior, and we know alternate exterior angles are congruent when lines are parallel. So we want to find the value of x that makes those two angles congruent. So we're going to set those two angles equal to each other. So we've got 3x plus 5, and we got 5x minus 17. So what value of x makes those equal? So we can start solving for x. So I'm going to subtract 3x on both sides. That's going to give me 5 equals 2x minus 17. Add 17 on both sides, and I get 22 equals 2x. Divide by 2, and we get x equals 11. So in order for those lines to be parallel, we would need x to be equal to 11. Next problem, kind of the same thing, all right, except this time we're looking at same side interior angles. Now remember, these aren't going to be congruent, okay? These angles are going to actually be supplementary, so we don't want to set them equal to each other. What we want to do is we want to add them together, and we want to set it equal to 180, okay? So if we add these together, we get 2 plus 79, that's 81. Then we're going to subtract that from both sides. So we're going to get 11x equals 99, divide by 11, and we get x equals 9. So in order for those lines to be parallel, we would need for x to be equal to 9. Okay. So last thing, we're going to do some proofs. Now these proofs are going to be pretty easy, okay? So can't really see here. It's given, okay, so we're being given that angle 8 is congruent to angle 9. Okay, so if we look in our picture, we've got angle 8, we've got angle 9, and it wants us to prove that the lines are parallel. And you can actually do this in only one step, okay, because these angles are alternate interior angles. And so if we're being given that they're congruent, okay, this is where we can use our alternate interior angles converse, which says if alternate angles are congruent, then the lines are parallel. So we know that the lines are parallel because of the alternate interior angles converse. All right. So the converse is always used when you're trying to prove lines are parallel. Right. It's not used for anything else. Last one. Given the information in the picture, is line M parallel to line N? Yes or no? Okay. So this might be kind of a hard proof. Okay. There's kind of a lot of steps here. Not hard, it's just kind of long. So we're going to kind of work through this. So given the information in the picture, so what is being given to us? Info in the picture, I guess. But anyway, or maybe not. Maybe that's not what we want to put for given. Sorry, guys. Let's actually make our first equation. So we want to try and prove that these lines are parallel. So we should probably figure out what x and y are, okay? So what's x going to be? Okay, well, we know that these two angles add up to 180, right? So let's go ahead and find x first. We've got 2x plus x equals 180. So that's given because that's in the picture. How would we solve this? 2x plus x, that's 3x equals 180. So here we're kind of using our solving steps. So that's combining like terms. Then we got to divide on both sides. So that means x equals 60. All right. So that would be, since we divided on both sides, that's our division property. We've also got, we got to find y, right? So we've got 3y plus 15 equals 190. What was that? Minus 2y. And those are vertical angles, right? So that's how we know they're the same. So we can say vertical angles as our reason there. So now again, we kind of want to start solving here. So we're going to have to add, the 2y to both sides. So that's going to be 5y plus 15 equals 190. So since we added on both sides, that would be our addition property. So we're kind of bringing back some old stuff here. All right. So this stuff still could be used in proofs. Now we have to subtract 15 on both sides. So we got 5y equals 175. That'd be subtraction property. And then we need to divide by 5 on both sides. So what is 175 divided by 5? Let's use our calculator. 175 divided by 5, that's 35. And so what are we going to do now? So now we need to try and prove that the lines are parallel. The way that we can do that is that we kind of need to prove that this angle right here is the same as that angle. The angles don't really have names, so I don't really know how we're going to be able to name them. Yeah, that's kind of a hard hard question. This isn't really a good picture here for us. We know this angle's got to be 120. So let's just make up a name for them right now. All right, that's angle 1, that's angle 2. So angle 1 equals 2 times 60. That'd be substitution. Which means angle 1 equals 120. That would just be, simplifying. We need to do the same thing for angle 2. So angle 2 equals 190 minus 2y. For y, we got 35. So that's 190 minus 2 times 35. That's also substitution since we plugged in 35 for y. And we can, 2 times 35, that's 70. 190 minus 70, that's 120. And so that would be, again, we're just, kind of simplifying over there. And so now we did it, right? We did what we wanted to do. We showed that angle 2 is equal to angle 1. And that would be transitive property since they're both equal to 120. And then since we showed that they're congruent and they are alternate exterior angles, now we can say that M is parallel to N because of alternate exterior angles converse. So again, we had to use the converse there, all right? Anytime you are proving that lines are parallel, you got to use the converse. So this is kind of a long proof, all right? We did it together. Hopefully this wouldn't be, out of your capability. Hopefully you could at least kind of figure it out. I do realize that it was tough though. Something like this would not be on a test. So hopefully this video was helpful. Hopefully you can do the practice based off this. If you have any questions, let me know, and have a great